everyone, and welcome to Feed and Green Chat. I'm your host, Elise Schaefer, editor of Feed and Green. This edition of Feed and Green Chat is brought to you by Watt Global Media and feedandgrain.com. Feedandgrain.com is your source for the latest news, product, and equipment information for the grain handling and feed manufacturing industries. Today, I'm joined on Zoom by Matt Zabel, Solutions Architect Digital Energy for Faith Technologies, a Wisconsin-based firm specializing in engineering, construction, manufacturing, and clean energy. Hi, Matt. How are you?
I'm doing good, Elise. Thank you.
Well, thanks for coming on today. Let's get right into it.
Okay.
Can you explain how power metering and power quality metering works? And what kind of information can it provide about an agricultural facility?
Sure. So a power meter, let's see, there's a couple of things that will come into a power meter. So in anticipation of this, I actually have a little cute basic energy meter here that I brought along. And for a device like this, if you want to meter, let's say, the main feed to a panel board or a switchboard, you're going to have a breaker or a fuse somewhere inside of the system that you're going to feed the power to this power monitor with. So it's going to be looking at all three phases of your voltage. Okay. And then that's going to give you a voltage signal. And then you're also going to have something called a current transformer, which is a coil. And typically we use a split core. I'll zoom that in there. We use a split core CT or current transformer so that the existing wire that's in the facility can go right through that current transformer and we can close it up. And what this device does, you can see the arrow on the front here. What this device does is without touching the wire, it can sense, because of the coils going around the wire, how much current is going through it. So then in my power meter, I have a voltage and I have a current, which means I can figure out how much power I have going through my circuit. Another thing, see that current transformer that we just looked at was pretty small. They also come in much bigger sizes for your larger feeds in your facility. They also come in split core varieties so that you can easily clamp them around existing wires, and we can put little safety pins in so that it doesn't come out. So once you get that signal with the voltage, the amperage to your energy meter, a basic energy meter is going to report out on things like volts, amps, kilowatts, kilowatt hours. It'll also tell you what your power factor is. Power factor, if any of you attended Jeeps, we talked about that quite a bit, where if your current is lagging your voltage because you have a lot of across the line starters in your facility, the utility can penalize you for that depending on what your rates and tariffs are. So that basic meter is going to be useful for tracking and trending your power usage. And it's also going to help you see as you make process changes, how are you conserving or how are you negatively impacting your electrical usage? And then over time, obviously, the goal with installing one of these is that you'll be able to make changes in your process and in your operations that will allow you to use less energy or to shift the energy usage to a time when you get charged less. Now, when you have a more advanced meter, that's when they start looking at things like harmonics, voltage disturbances, other concerns. It can kind of help you understand all of our power in the United States is a 60 hertz wave. And that 60 hertz wave should be a nice, clean sine wave. Well, some of the more advanced meters can help you understand how dirty or noisy that power is that can damage equipment like drives, LED motors. And then finally, one more item, there's power quality meters. Power quality meters have all the same pieces. But, I talked about that 60 hertz wave on your voltage and your current. The power quality meter is sampling that waveform at a very high rate of speed, between like 8,000 and 60,000 samples a second. So when you have a brownout in your facility or an unexpected equipment shutdown, these devices can help you understand specifically what type of power quality issue do you have. Was it a voltage sag, a voltage swell? How bad was it? Did the utility cause it? Was it from something inside your facility? Power quality meter is also going to catch things that maybe didn't shut you down, but aren't being kind to your equipment. When there's little voltage drops here and there or little voltage swells here and there, your equipment can be electrically beat up. The capacitors inside of the equipment can get beat up and they don't last as long. So as a company, we always encourage clients at a minimum to install a power quality meter with their new switchboards, because if you ever have a power quality issue, they quickly pay for themselves.
What are the first steps that need to be taken or equipment involved in implementing a metering and monitoring system?
Step one is really sitting down with a technical expert in these systems to discuss what your company's goals are and talk about what you're experiencing right now at your facilities. You need to answer questions like, are we going to expand someday? Are we going to want to add solar someday? What about an EV charger for some on-site trucks or some small tractors? Then it's also really important to ask yourself, who's going to look at this data and what benefit do we expect to get from this? And then also we need to answer the question, what information would the system need to provide for anyone reporting on sustainability information for our company? We want to design it answering those questions in mind. The next step after you answer those questions, after the needs are defined, would be building a budget with that technical expert and adjusting the concepts of what the system would include to meet the needs. At this point, it's pretty important that some sort of an operational leader is involved to give sign off on the budget and sign off on the scope of where things are going. And then finally, at that point, work with your trusted provider or a couple trusted providers to get you a proposal to implement that at your facility.
What are the long-term benefits or cost savings that can be expected from a system like this?
Well, Department of Energy studies, when they looked at a metering and monitoring system put in buildings, show a 3 to 20% energy cost reduction when someone's actually acting on the data from a metering and monitoring system. Now, as a company, we tend to be a little bit more conservative and we say 3 to 10% energy cost savings in a grain elevator. You add VFDs and other automation into your conveyance, dust, and aeration systems. The metering is going to help you dial in the right ramp rates and automation settings to save energy costs. It's also going to help you justify automating other parts of your facility. Because let's say there was a very large conveyor that you put a VFD on and you automated it to ramp up and ramp down at certain times to save energy. Well, now with the meter that you've installed, you have the data to show what you saved there to go back to operations leadership and get more money to do the next conveyor.
Well, thank you so much for your insights today, Matt.
Thank you very much, Elise. It was really nice talking to you.
Yes, likewise. That's all for today's Feed and Grain chat. If you'd like to see more videos like this, subscribe to our YouTube channel, sign up for the Industry Watch daily e-newsletter, or go to feedandgrain.com and search for videos. Thank you again for joining, and we hope to see you next time.